Far beyond the warm glow of stars, in the deepest parts of space, there are worlds that drift alone. They do not feel the sunrise. They do not orbit a sun. They travel endlessly through darkness, frozen and silent. These are rogue planets, worlds without a home. Imagine a planet the size of Jupiter, moving through space with no star to guide it. No dawn, no seasons, only eternal night. Its sky is a black ocean. No constellations, no sun or moon, only distant starlight, faint as grains of sand scattered in infinity. These planets roam through the Milky Way, hidden like ghosts. They were born in star systems, but something went wrong. A violent collision, a gravitational war, a push from a giant planet stronger than anything we know. And so they were cast out, exiled into the darkness between the stars. For decades, scientists debated whether such worlds even existed. Today, we know they do. Some drift alone. Others may carry frozen moons, deep oceans, or volcanic fire beneath ice. Some may even steal warmth from ancient cores, glowing faintly with leftover heat from their birth. These wandering giants do not reflect sunlight. They are invisible to the human eye. And yet, astronomers have found them using the faint bend of starlight, the heat of infrared radiation, and the mathematics of gravity itself. They challenge everything we thought we knew about planets. They may be more common than stars. There could be billions of them in our galaxy, drifting silently in the dark. What are these planets like? Where do they come from? And could life survive on a world without a sun? This is the hidden story of rogue planets, lost worlds, frozen giants, embers of creation traveling alone through the endless night. To understand rogue planets, we must first understand ordinary planets. In a typical solar system, planets are born from swirling clouds of gas and dust around a newborn star. Gravity pulls this material together. Small rocks become mountains. Mountains become worlds. Some become rocky planets like Earth. Others grow into giants like Jupiter. But sometimes, this process does not end in stability. Sometimes, a planet is formed and then exiled. A rogue planet is a planet that does not orbit any star. Instead, it travels freely through space, moving only under the influence of gravity from the galaxy itself. Scientists believe there are two main ways rogue planets are born. In many young star systems, planets do not form peacefully. They fight for survival. Giant planets pull on each other with massive gravitational forces. Smaller planets are easily caught in the crossfire. If two giant planets pass close to each other, one may receive a powerful gravitational kick. This shove sends the smaller planet flying into space, never to return. This is not rare. In fact, scientists believe that nearly every star system throws at least one planet away during its early history. Our own solar system may have once had more planets. Some could have been thrown out during chaotic beginnings, never to be seen again. Some rogue planets are not born around stars at all. Instead, they form like stars, directly from collapsing clouds of gas. But they never gain enough mass to ignite nuclear fusion. They are called sub-brown dwarfs, or failed stars. Too small to burn, too large to be called true planets. They drift alone, glowing faintly with leftover heat from their birth, slowly cooling over billions of years. These worlds, born in chaos or in silence, become cosmic wanderers. Some are as small as Earth. Others may be larger than Jupiter. Some are icy. Others are made of gas and storms. Some may even have moons still orbiting them, forming tiny solar systems drifting through the void. They are planets without a sunrise, worlds without a sky. And yet, they are real. But how many are out there? To understand rogue planets, we must travel back to the earliest days of star and planet formation. Every star, including our sun, is born inside massive clouds of gas and dust. Gravity forces these clouds to collapse, and as the material spins inward, It forms a flat rotating disk around the young star. Inside this disk, small particles collide and stick together, growing into rocks, then into mountain-sized objects, and eventually into planets. But this process is violent and chaotic. Planetary systems do not form peacefully. They are built from collisions, gravitational tug-of-war, and instability. Sometimes, two giant planets form too closely together. Their gravity interacts, and one planet can be flung outward like a slingshot. If it gains enough speed to escape the gravity of its star, it is thrown into the cold darkness of space. From that moment on, it becomes a rogue planet, no longer attached to any solar system, drifting alone. In other cases, young stars form close to one another in star clusters. Their gravity can pull on forming planets and steal them from each other. A passing star may come too close and rip planets away from their original home. These planets wander off, with no sun to orbit. Rogue planets can also form differently. Some may not have formed around a star at all. Instead, they form directly from collapsing gas clouds, like small failed stars. These objects are sometimes called sub-brown dwarfs. They are too small to ignite nuclear fusion like stars do, yet too large to be considered ordinary planets. They float through interstellar space, dark and cold, but still shaped like worlds. Astronomers believe there could be more rogue planets than stars in our galaxy. Some estimates suggest that for every star in the Milky Way, there might be 2 or 3 rogue planets wandering in the dark. Some scientists even think there could be billions of them, making rogue planets one of the most common types of worlds in existence. Yet finding them is extremely difficult. Without a star to light them up, they are nearly invisible. They do not reflect sunlight. They do not give off light of their own, except for a faint thermal glow if they are still young and warm. The only way astronomers can detect them is through rare gravitational events, when a rogue planet passes in front of distant stars and briefly bends their light. This is called gravitational microlensing, predicted by Einstein's theory of general relativity. It is a powerful method, but unpredictable and short-lived, lasting only hours or days. Despite these challenges, scientists have already discovered several candidates. The most famous are from a star-forming region called Upper Scorpius, where a group of large rogue worlds, some similar in size to Jupiter, have been detected floating freely between the stars. Another discovery was made when the telescope caught a rogue planet only about 100 light-years away, wandering alone with no star to guide it. These worlds challenge everything we once believed about solar systems. Planets are not always tied to stars. Some are born in light, but condemned to spend eternity in darkness. And yet, even in their loneliness, they may hold secrets about how planets form, about the power of gravity, and perhaps even about life itself. Imagine standing on the surface of a rogue planet. There is no sunrise, no sunset, no warm glow of distant starlight. Above you stretches an endless black sky, filled only with cold stars that never move. There is no sky blue, no day, no night, only eternal darkness. Without a sun, temperatures on most rogue planets would plunge to unimaginable extremes. The surface could be colder than -200 degrees Celsius. The air, if there is any, might freeze and fall to the ground like snow. Winds would be silent, thin, and bitterly cold. Oceans, if they ever existed on the surface, would be locked beneath kilometers of ice. Yet, despite this frozen silence, something extraordinary might lie below the surface. Some rogue planets could be large, with molten cores still radiating heat from their formation. Just as Earth's core remains hot long after its birth, a rogue planet could keep internal warmth for billions of years. Under thick layers of rock and ice, subsurface oceans might exist. Vast, dark seas, warmed by geothermal vents. These oceans would be shielded from the freezing vacuum of space, protected from radiation, and could remain liquid for millions or even billions of years. If a planet starts as an Earth-like world before being ejected, it might carry its atmosphere with it for a while. A thick atmosphere of hydrogen could trap internal heat and act like an insulating blanket. In this kind of world, the surface might be cold, but not frozen solid, perhaps even warm enough for liquid water to exist. Some scientists have proposed that Earth itself could remain habitable for a long time, even if it were thrown out of the solar system. Such planets are called Steppenwolf planets, worlds that roam like lone wolves across the galaxy, surviving in isolation. Life, if it exists there, would not see sunlight. It would not depend on photosynthesis. Instead, it would live like the organisms deep in Earth's oceans, near hydrothermal vents. On our planet, entire ecosystems thrive in total darkness, using chemical energy instead of sunlight. If life can do it here, could it do the same in the endless night of a rogue world? Nobody knows for sure, but it is possible. To explore these silent planets would be one of humanity's greatest challenges. No sunlight means no solar power. Spacecraft would need nuclear energy to survive. Landing on a rogue planet would be like stepping into a lifelong polar night. Communication with Earth would take years, maybe decades, depending on how far the planet has drifted. Yet the mysteries they hold, frozen oceans, internal heat, possible life, make them some of the most fascinating destinations in the galaxy. Rogue planets are not just dark, cold worlds. They are testaments to survival, to motion without guidance, to existence without light. They remind us that the universe is not built only on warmth and brightness. It is also shaped by darkness, gravity, and silence. Life on Earth depends on sunlight. Plants convert sunlight into energy. Animals eat plants or other animals, and almost every ecosystem traces its roots back to the sun. So can life exist on a planet drifting forever in darkness? At first, the answer seems like no. Without sunlight, there is no photosynthesis. Without a star's heat, everything should freeze. But life on Earth has already shown us that it does not always follow these rules. Deep beneath the ocean, far from any sunlight, there are ecosystems powered by heat from inside the Earth. Around hydrothermal vents, cracks in the seafloor release hot, mineral-rich water. Here, in total darkness, bacteria use chemical energy instead of light to survive. These bacteria support entire communities of worms, crabs, fish, and other strange creatures. They prove that sunlight is not always required for life. A rogue planet with a warm internal core could have similar conditions. If an ocean exists deep below its frozen crust, it might be heated from within by radioactive decay or residual planetary heat. Hydrothermal vents could form under the pressure of thick ice and rock. In these dark oceans, microbes could live just as they do at the bottom of Earth's seas. Even more surprising, scientists have discovered creatures on Earth that survive in some of the harshest environments imaginable. Microorganisms called extremophiles live inside ice, in boiling acid pools, under crushing ocean pressure, and even inside rocks. Some can survive complete freezing and come back to life centuries later. If life can survive here, why not out there? Another possibility is life powered by chemical reactions between rocks and water, a process called chemosynthesis. This requires no sunlight, only liquid water and certain minerals. If a rogue planet has both, life could emerge, slowly, quietly, deep below the surface. However, life on rogue planets would be very different from life on Earth. There would be no forests, no skies, no day or night, no stars, no sunrises. Just black ice above, black water below, and life clinging to heat and chemistry in the dark. Could intelligent life evolve in such a place? Scientists believe it would be extremely difficult. Without light, vision may never develop. Without a sky, there would be no stars or seasons to inspire measurement or timekeeping. Without plant life or large food chains, energy would be limited. Life could exist, but it might remain microscopic, slow, and primitive. Still, even the smallest life would be one of the greatest discoveries in human history. If we ever find microbes swimming in the oceans of a rogue planet, it would mean life does not need sunshine. It does not need a star. It only needs water, energy, and time. It would mean that the universe, even its darkest corners, is more alive than we ever imagined. Finding a planet orbiting a star is hard, but finding a planet floating alone in complete darkness is one of the most difficult challenges in astronomy. Rogue planets do not shine. They do not reflect sunlight because they have no sun. They do not pulse like stars or emit strong radio waves. They are colder than ice, smaller than stars, and lost in the empty space between solar systems. So how do scientists even know they exist? Astronomers use a phenomenon predicted by Albert Einstein called gravitational microlensing. According to Einstein's theory of gravity, a massive object can warp the space around it. When a rogue planet passes in front of a distant star, its gravity bends the star's light. For a short moment, the star appears brighter. Then it fades back to normal. The planet remains invisible, but its gravity leaves a brief fingerprint in the light. These events are rare and unpredictable. They last only a few hours or days. Astronomers must monitor millions of stars every night to catch them. Projects like the optical gravitational lensing experiment in Chile and the Kepler Space Telescope have detected these signals. Some events were so short and sharp that they could only be caused by planets drifting alone. Another method uses infrared telescopes. Although rogue planets are cold, young ones still hold leftover heat from their formation. This heat glows faintly in infrared light. Telescopes like the James Webb Space Telescope and the European Space Agency infrared missions search for these faint glimmers. In 2021, astronomers announced the discovery of over 70 possible rogue planets in the Milky Way. They were found in a star-forming region called Upper Scorpius. These planets drift freely, untethered to any star. They are between 4 and 13 times the mass of Jupiter and shine only with their fading heat. More may exist that are too small or too cold to detect. Some scientists even believe there could be billions of rogue planets in our galaxy. Some estimates suggest that for every star, there may be one or more rogue planets wandering silently through the dark. If this is true, space between stars may not be empty. It may be filled with worlds. Perhaps some of them once had suns. Perhaps some still have oceans under frozen crusts. Perhaps some hold the earliest forms of life in the universe. But to confirm this, we must find them, study them, and someday travel to them. The search has only begun. In the silence between stars, there are worlds that know no sunrise. No morning light touches their surface. No warmth of a parent star guides their seasons. They drift alone, carrying the memory of where they once belonged, or perhaps never belonged at all. These are rogue planets. They follow no orbit, no rhythm, no light, and yet they exist in greater numbers than we once imagined. Silent travelers through the dark, cold, abandoned, yet still holding the shape of a world. Perhaps beneath their frozen surfaces, there are oceans warmed by the heat of their cores. Perhaps deep in the darkness, there are volcanoes, buried oceans, or chemical reactions that never see daylight. If life does not need sunlight, then even a world without a sun could still breathe. The mystery of rogue planets is not only scientific, it is deeply human. They remind us of loneliness, of drifting far from home, of searching for light in a place where there is none. Yet they also remind us of resilience, to keep moving, to keep existing, even in darkness. For astronomers, rogue planets challenge everything we know about planetary systems. They rewrite the rules of how planets are born and where life might thrive. They force us to ask a simple question. Does life require a star? Or does it only require time, water, chemistry, and a little heat in the right place? If there are billions of rogue planets in our galaxy, then the universe may be full of hidden homes. Worlds that do not shine, but endure. Worlds that wait to be found. And someday, far in the future, when humanity has left Earth and sails between the stars, perhaps we will land on one of these hidden worlds. We will step onto a silent surface, look up into a sky with no sun, and light our own. In that moment, a world without a star will no longer be alone. Thank you for traveling through the darkness of space with me. If you would like to continue exploring the unknown, make sure to subscribe. The universe is vast, and our journey is only beginning.